Alright, so this is the square one tutorial. Let's get right to it. So, you have a square one. It's probably not solved and you probably don't know how to solve it, which is why you're watching this. To start off, before we get into more algorithm heavy stuff, is we have to distinguish the differences between a 3x3 and a square one. So obviously the first thing that's apparent is that the edges and corners are irregular, and this irregular shape and this axis only allows it so you can only do essentially 2-gen stuff, but it's different in that you can mix it up. You can put two edges next to each other. And this, I mean, no matter how hard you try, you can never put two edges next to each other on the same layer, like this anyway. So, now throughout this tutorial, and how most people solve the square one, is they always want to solve it with the square one, or if you have a cubo2 logo, facing on the left side. This will be your grip, and you will never, ever do an equivalent of L2. You'll always just do R2. Alternatively, you can turn it over and use this. It's the same thing, except that the square one will always be facing one way or another. And for solving the square one, it's always easiest if it's on the left side. The other one that's very important is the notation. The notation on this one is, of course, just U, R, R prime, and nothing that really separates the notations. On this, you have 1, -1, dash. Or alternatively, you have -2, 2, dash, and so forth. To read notation for a square one, it's very unusual. Basically, the edges are 1, or worth 1. The corners are worth 2. So if a notation says -3, comma 0, we have -3, and we don't do anything to the bottom. Now the first number relates to the top layer. If it's positive, it means clockwise. If it's negative, it means counterclockwise. And same thing goes for the bottom layer. And like the difference between R and L prime, or F and B prime, the counterclockwise is always relative to the side. So we have F and F prime, and although you might think for a while, well, oh, this, or beginners often think this is B, but it's actually B prime. So same thing right here. A 1 on the top is not a 1 on the bottom, but rather a -1. And a dash in the notation signifies an entire turn, as you can't do a single turn as it locks it up. So the final example of the notation is we have 1, -4, dash. And again, it's always to how many edges there are. In a case like this, 2 on the top layer is still just 2, and 4 is still 4. So again, the corners are worth 2, and the edges are each worth 1. And the final difference between a 3x3 and a square one is that a 3x3 middle layer is always oriented, and no matter what, it'll always be in a cube shape. But with the square one, the middle layer is independent from the other layers and can be misaligned. And we'll talk about how to fix something like a problem like this later. So while the other two layers may be square, the middle layer will not be, but it doesn't matter. Okay, so let's get started on actually solving it. Alright, so your square one is scrambled. Obviously the first thing that we're going to be trying is getting into a square shape. It's the most logical course of action. So there are numbers of ways to get into square shapes. You can either memorize all these different permutations and all these different shapes to get it into a full cube, or we can get it into a mixed up position, and then from that, or we can memorize that one position and get into a cube. In this case, we're going to be aiming for this position, where we have all the edges on the top and 2 corners, and the rest of the corners are on the bottom. It doesn't matter what color they are, just as long as it's in this shape. Now, getting into this shape isn't always that easy, obviously. But there are certain patterns of shapes that we can look out to get it into this particular position. One of them is opposite edges like this. The opposite edges are flat, and when combined with other flat edges, they can make 2 of them at a time. Typically, though, it's usually added to the other set of 6. Another shape we can look out for is the two paired edges like this. And typically what we can use these two edges to do is to pair them up with other sets of 2 edges, or 4 edges, or any even number of edges. And the final shape of the combination of edges that we have to watch out for is this L shape. The problem with this L shape is that while the other 6 may be paired together, it proves difficult to pair these 2 edges because you still have 2 edges. You can't get them to easily mold with the others, the other 6, into that semicircle pattern. Now there are many ways to solve this L edge like this. While we can't go through all the patterns that correspond with the last layer, we can improvise and to demonstrate how most of them work is by setting them on the top layer. Rather than just turning it back down, we have to offset it a lot. And this is mostly, I've mostly figured this out through experimentation. But if you keep experimenting with the turns, you can eventually get it divided up into where you have 2 opposite edges, and you have 2 paired edges on the bottom. And then combine that, and we have all 6 of them, and we have opposites, and we can pair them up. So to get this semicircle pattern, you have to understand the edges and how they get paired up and how to manipulate them overall. Now to get it from this shape to a cube, have the semicircle facing you. It doesn't matter which axis this is on. We have dash, -2, -4, dash, -1, -2, dash, -3, -3, dash. And that gets into a square. Now, once the top layer and the bottom layer are in a square shape, we can then start orienting the corners. And so there are many ways to orient the corners. The way that I like to do it is get the green side on the top, and for the later steps it's more convenient to work on the green side first, which typically goes on the bottom, and then the white side. So we're going to get all the green corners paired up on the top layer. Now if there's one corner on the top, there's always 3 on the bottom in some sort of L shape like this. To divide them up, 2 on the side, 1 corner, and send the corner to the top layer. But make sure that you can still send it to the top in a square. So you always want to misalign one of these layers so that it maintains its square shape on the top and bottom layers. And then once we have 2 on the top and 2 on the bottom, again we have to keep one layer misaligned and just dash. And so again, all the corners are oriented. Another combination is if the corners are diagonal on the top and the bottom layers. To do this, it's pretty easy again. You always want to misalign one layer. If the bottom layer, green corner in the top right, dash, and these will be paired up now. And now all the corners are oriented. Now if we have any of these corners on the top layer and only 1 corner on the bottom layer, it's essentially the same thing as having 1 corner on the top layer and 3 on the bottom. So for this we want the 1 corner up there, misaligned layer, pair up the 2 corners, and bring the other 2 back. So pairing the corners, orienting the corners is relatively intuitive, and we don't really need algorithms for it per se. Now we move on to the next step of orienting the edges, or getting the edges all to their right layer. And this is where we need more algorithms.